Hello there. I didn't see you there. My name is Grant, and today we're going to go over a rotational work problem. All right, let's look at this puppy. All right, how much work do you do if you apply a torque of 6.0 Newton meters over an angle of 200 radians? So let's draw a picture. That's the best way to start any problem. So got our little point over here. We got the center, we have a radius, and we have the torque that's going to be applied. Let's say it's going in a counterclockwise fashion, but it really doesn't matter for the sake of this problem. So first of all, let's just get a common sense grasp of how far we're moving this mass. So we have a number of 200 radians right here. If we take a circle and we want to go around from here one time, that is going to be 2 pi radians, which is approximately 6.3. So we're actually rotating this a lot of times. Back to the problem. Now we've got a grasp about what we're actually going to do. So we're going to take this, we're going to move it around a lot. So what we're going to do is go back to the formula that we learned in the last lecture. Right here. The rotational work is equal to the torque times the angle rotated through. So now that we have that, let's write out what we know. We know the torque. We know the angle. The question is asking us for the amount of work done. So let's see if we have all the parts to find the work. So we're looking to find this. Do we have the torque? Yes. Do we have the angle? Yes. So we can just plug and chug like Thomas the Train. So the work is going to be equal 6.0 Newton meters times 200 radians. So the result of this is going to be 1,200 Newton meters. So now, an important thing to remember about the units. This one is in Newton meters. This one is in radians. Radians, as you might recall, are not actually a unit in the same sense that a Newton or a meter is, that where it's defined by the physical world around it. A radian is really, when it comes down to it, a ratio. So that drops out and we're left with Newton per meters. And it's a good thing to just kind of check when you're done with a problem if you have the right units. So I always go back to the simple projectile definition. Force is equal to, work is equal to force times distance. So what are the units of force? That would be a Newton. And what are units of distance? In the SI system, that would be a meter. And note, it checks out. Now you don't need to do this every problem. I'm just giving you a resource for what you can do if you do ever get tripped up with units. All right, I'm singing Sayonara, gonna see you tomorrow.